The journey begins not with a step, but with a disintegration of scale. You are standing on what seems like solid ground, but it is an illusion. The jungle floor is not a foundation, it is a ceiling. A ceiling for a world that operates in millimeters and millennia. Bend down. Your field of vision shrinks from sweeping vistas to a single square foot. Suddenly, a single leaf, fallen from a canopy 100 feet above, is a continent. Its veins are mountain ranges, its tiers and holes are caverns. This leaf, once a solar panel for a giant, is now a caucus, and its decomposition is the ignition key for the entire jungle system. But it doesn't just rot, it is contested. The first soldiers you see are the fungi, not the mushrooms, but the ghostly, microscopic threads called hyphae. A single gram of this soil can contain kilometers of these fungal filaments. They are the assassins, exuding powerful acids and enzymes that can dissolve the tough lignin in wood, a substance so resilient that only they, and a few bacteria, have mastered its breakdown. They are the primary decomposers, turning dead matter into accessible chemicals. But they are not alone. Enter the detritivores, an army of shredders. Tiny springtails, like living silver fleas, chew mechanically. Mites of 1,000 species, some looking like miniature armored tanks, scuttle and graze. Millipedes, the conveyor belts of the forest floor, process volumes of material, their guts, filled with symbiotic bacteria that further break down cellulose. This is the first layer of the silent war, the war against death itself, turning organic matter back into its fundamental parts. Every rainstorm, every fallen branch, every animal corpse is a sudden influx of resources triggering frenzies of activity. But the data reveals a staggering truth. Less than 10% of the energy from a leaf goes into building the bodies of these tiny shredders. The other 90% fuels their immense activity and is lost as heat. They are not consuming for growth so much as they are engines of dissolution. And their metabolic heat is what gives the jungle floor its distinctive, warm, humid breath, a literal thermal signature of life at work. This process, this constant cycling, is what makes tropical soils so notoriously infertile for agriculture. The nutrients are not stored in the soil. They are locked in a frantic, rapid conveyor belt running from dead matter through decomposers and directly back into the roots of living plants. The soil is a transit lounge, not a warehouse. It's a lean, efficient system with zero waste. Now look closer at those fungal threads. They are not just random webs. They form structured networks. And some, like the mycorrhizal fungi, don't just decompose dead things. They actively seek out living tree roots and form partnerships. This is where the story shifts from decomposition to communication. The fungus, with its vast web, acts as an extension of the tree's root system, foraging for water and scarce minerals like phosphorus. In return, the tree pays a price in sugars, photosynthesized from the sun. This trade is the bedrock of the jungle, but recent research using isotopic tracers has shown something mind-blowing. These fungal networks, dubbed the Wood Wide Web, don't just connect a fungus to one tree. They connect multiple trees, even of different species. And they aren't just pipes for water and nutrients. They are channels for information. When a tree is attacked by insects, it can release chemical signals through these fungal wires to warn its neighbors, who then preemptively ramp up their own chemical defenses. Mother trees can shunt carbon and nutrients to their own seedlings struggling in the understory shade, giving them a leg up. The forest, it turns out, is a cooperative society, a neural network mediated by the fungal matrix in the soil. This challenges the Darwinian notion of a purely competitive struggle for existence. Here, on the jungle floor, there is sophisticated collaboration, a shared economy that stabilizes the entire ecosystem. The soil is the internet of the forest, and its broadband is biological. Beneath the fungal networks lies another kingdom, one of even smaller but unimaginable powerful entities, the bacteria. If fungi are the internet cables, Bacteria are the power plants, the chemical refineries, and the special forces operatives. A teaspoon of jungle soil contains billions of bacterial cells, representing tens of thousands of species, most of which have never been cultured or named by science. They exist in microhabitats smaller than a grain of sand, a pore of water, a fragment of organic matter, the rhizosphere, the zone immediately surrounding a root. Their diversity is the soil's true genetic library and its adaptive engine. Some of these bacteria are nitrogen fixers. They possess the magical enzyme nitrogenase, which can break the powerful triple bond of atmospheric nitrogen N2 that is inert to plants and animals, and convert it into ammonia NH3, a form of nitrogen life can use. This is arguably the most important biochemical reaction on the planet after photosynthesis. Without it, life as we know it would grind to a halt. In the jungle, some of these fixers live freely in the soil, but the most important ones form symbiotic relationships with plants, most notably in root nodules of legumes. But the jungle floor's bacterial warfare is even more intense. Consider the leafcutter ants you might see marching in lines, carrying leaf fragments like sails. They are not eating the leaves. They are farmers. They take this plant material into vast underground chambers and use it as a substrate to cultivate a specific species of fungus which they then eat. But how do they keep this fungal garden from being overrun by a parasitic mold called Escovipsis? They employ an army of antibiotic-producing bacteria. The ants cultivate these bacteria on their own bodies in special cavities and use the antibiotics as a weed killer to protect their crop. This is agriculture, complete with pest control, millions of years before humans invented it. The chemical complexity here is staggering. These soil bacteria are the world's best chemists, producing a vast arsenal of compounds to fight, communicate, and manipulate. In fact, over 2/3 of all known antibiotics originate from soil bacteria like streptomyces. The next miracle drug for a drug-resistant superbug is statistically likely to be hiding in the metabolic pathways of a bacterium living right here in the competitive pressure cooker of the jungle floor, where producing a potent weapon is a matter of life and death. This leads us to the concept of the microbial loop. Dissolved organic matter leaked from roots or from decomposing material is too small for even fungi to consume directly. This soup is the domain of bacteria. They absorb it, incorporate it into their biomass, and then become prey for a host of even smaller predators. Protozoa, single-celled organisms like amoebae and flagellates and nematodes, microscopic worms. When these predators eat the bacteria, they excrete the nutrient in a mineral form, like ammonium, that plants can readily absorb. So, a molecule of sugar from a tree root can be taken up by a bacterium, which is then eaten by an amoeba, which then excretes a form of nitrogen that feeds the tree. The tree has effectively fed a bacterium to a protozoan to get its fertilizer delivered. This tight, rapid cycling is why tropical ecosystems are so productive despite poor soil. It's a closed loop, hyper-efficient economy. But the floor is also a massive carbon vault. All this organic matter, in various stages of decomposition, represents stored carbon globally. Soil contains more carbon than the atmosphere and all plant life combined. The jungle floor, with its rapid turnover, is a dynamic carbon sink. However, when the forest is cleared and the soil is exposed, this carbon, especially from the deep organic layers, oxidizes and is released as CO2. The data is chilling. Deforestation and land use change contribute roughly 12 to 20% of global anthropogenic greenhouse gas emissions. And a significant portion of that comes from the disturbance of the soil carbon pool. That warm, moist, living carpet is not just life. It's a climate regulator. Disturb it, and you release millennia of stored carbon in a geological instant. This intricate bacterial world also mediates other crucial cycles: phosphorus, sulfur, iron. They can make minerals soluble or insoluble, toxic or benign. They are the ultimate geoengineers, quietly governing the chemical foundation upon which the towering jungle rests. Without this unseen, bustling metropolis of microbes, the green cathedral above would collapse into a skeleton of dead wood. While microbes handle the molecular scale, the jungle floor is also shaped by larger, more visible engineers whose daily activities physically remodel the entire landscape. These are the ecosystem engineers, and their labor is so profound that if they were to vanish, the structure and function of the floor would change catastrophically. The most obvious are the earthworms, but in tropical jungles, their role is often surpassed by more exotic players. Take termites. In many tropical regions, termites are the dominant decomposers of deadwood. But some species are master builders. They construct colossal, ventilated mounds that can tower over the understory. These mounds are not just homes, they are nutrient hotspots. The termites bring up deep, mineral-rich subsoil to build with, and their constant foraging and waste deposition concentrate nutrients like phosphorus and calcium. Over centuries, these mounds become islands of fertility. When a mound is abandoned, it erodes slowly, creating a resource-rich patch that influences plant succession for decades. Studies have shown that tree diversity and growth can be significantly higher on and around old termite mounds. They are landscape-scale nutrient pumps. Then there are the mammals. The lowland tapir, a living fossil, is a seed dispersal giant. It consumes vast quantities of fruit and, through its defecation, deposits seeds far from the parent tree, often in nutrient-rich latrine sites, giving them a better chance. But its impact on the floor is more physical. Its trails and wallows create microdepressions that hold water, becoming temporary ponds for insects and amphibians. Peccaries, wild pig-like animals, root through the leaf litter and sounders, overturning soil in search of tubers and invertebrates. This soil bioturbation is crucial. It aerates the soil, mixes organic layers, buries seeds, and creates germination sites. It's a constant, natural tilling service. Even the massive elephant is a floor engineer. By pushing over trees or breaking branches, it creates light gaps, sudden openings in the canopy where sunlight pours onto the forest floor. This triggers a rapid succession of growth, from fast-growing pioneer plants to slower-growing saplings, increasing structural diversity. Its dung, a massive package of semi-digested fiber, is a micro-ecosystem in itself, a breeding ground for dung beetles and a nutrient deposit that can feed a small area for months. The dung beetles are a critical link. They rapidly bury and consume dung, preventing the spread of parasites and, most importantly, incorporating this nutrient-rich material deep into the soil profile. They are the sanitation crew and soil mixers rolled into one. Research using pitfall traps has shown that in healthy jungles, dozens of dung beetle species can coexist, each specializing in different types of dung at different times. A beautiful example of niche partitioning. But the engineering extends to reptiles and amphibians. Many frogs, like poison dart frogs, lay their eggs in the moist leaf litter or in tiny water bodies in bromeliads or fallen logs. The tadpoles that hatch contribute to nutrient cycling in these micropools. The fallen logs themselves, called nurse logs, are monumental features of the jungle floor. A giant tree falls, and as it decays, it becomes a raised, moist, nutrient-dense strip of real estate. Mosses and ferns colonize it first, then tree seedlings sink their roots into its spongy mass. For decades, a line of trees may grow in a straight line, their roots tracing the outline of the log that nourished them. The log is both a seed and a slow-release fertilizer pill. The physical structure of the floor, its topography, its porosity, its moisture retention is a palimpsest written by the activities of these engineers over centuries. Their trails become water channels. Their diggings become tree fall pits. Their mounds become small hills. This constant physical restructuring creates a heterogeneous habitat with countless microenvironments, which is the very engine of the biodiversity we see at larger scales. Remove the tapirs, the peccaries, the termites, and the floor becomes a flatter, more homogeneous, and ultimately less productive place. The data from exclusion experiments is clear. Areas fenced off from large mammals show reduced soil turnover, altered seed dispersal patterns, and changes in plant community composition within just a few years. These animals are not just inhabitants of the jungle. They are its custodians and architects, their daily routines literally sculpting the foundation of their world. The intricate silent war on the jungle floor is now facing a cacophony of external threats that are disrupting its ancient equilibriums. The primary driver is, unequivocally, deforestation. When a forest is clear-cut, the immediate impact on the floor is apocalyptic. The protective canopy is ripped away, exposing the moist, shaded, temperature-stable environment to the full force of sun and rain. Soil temperature can spike by 10 to 15 degrees Celsius in minutes. The delicate microbial communities adapted to steady warmth are cooked or desiccated. The fungal networks dependent on living tree roots are severed and die. The sudden deluge of rain, without the canopy to intercept it, leads to catastrophic erosion. The topsoil, that rich, living layer that took millennia to build, can be washed away in a single rainy season. Satellite and ground sensor data show that cleared tropical lands can lose over 200 tons of soil per hectare per year. What remains is a hard, red, mineral subsoil, depleted of organic matter and life a biological desert. The carbon stored in that soil is released. Studies estimate that the first few years after deforestation see a loss of over 40% of the soil's original carbon stock. But the damage isn't only from clear-cutting. Fragmentation breaking up large forests into smaller patches creates edge effects. Up to hundreds of meters from a forest edge, microclimates change. Wind penetration increases, drying out the litter. Invasive species, like fast-growing grasses, often flood in from adjacent cleared lands their root system, and litter chemistry being alien to the native soil food web, further altering microbial communities. The larger engineers, the tapirs, peccaries, even dung beetles require large, continuous territories. Fragmentation traps them in islands, leading to local extinction, which then cascades through the ecosystem functions they supported. A second major threat is climate change itself. Altered rainfall patterns, more intense droughts, or more unpredictable floods stress the system. During droughts, the leaf litter dries out, decomposition slows, and the risk of catastrophic ground fires, once nearly unheard of in healthy rainforests, increases dramatically. These fires don't just burn trees. They incinerate the soil organic matter, sterilizing it and causing long-term damage to its structure and fertility. Data from the Amazon and Indonesia show that fire-degraded forests have significantly lower soil fauna diversity and carbon content even decades later. Furthermore, rising temperatures can accelerate microbial respiration, meaning the microbes in the soil consume organic matter faster, potentially turning the soil from a carbon sink into a carbon source. On a massive scale, a terrifying positive feedback loop. Pollution is a more insidious threat. Atmospheric nitrogen deposition from agriculture and industry carried by wind can fertilize these natural and nitrogen-limited systems in a lopsided way, favoring certain fast-growing plants and altering the competitive balance. Heavy metals and pesticides from upstream activities can accumulate in the soil, poisoning the microbial and invertebrate engineers. The silent war is being overwhelmed by a blitzkrieg of human-induced changes. Perhaps the most profound insight from recent science is that the recovery of a forest is not just about planting trees. You can plant 1 million saplings, but if the soil ecosystem, the fungal networks, the bacterial refineries, the engineer populations is gone, the forest will be an empty, dysfunctional shell. It will lack resilience, cycling nutrients slowly, storing less carbon, and supporting far less life. The soil memory has been wiped. True restoration requires healing the floor first, reintroducing not just plants but the complex below-ground relationships. This is the great challenge of our time. We must protect not just the jungle we see, but the jungle we don't. Every hectare preserved is a library of microbial genes, a living carbon bank, and a masterpiece of co-evolution that we do not know how to rebuild. Understanding the silent war beneath the jungle floor shifts our perspective from one of distant admiration to one of urgent personal responsibility. The fate of these complex worlds is inextricably linked to our daily choices. This isn't a remote issue. It's connected to the food on your plate, the products you buy, and the voices you support. So what actionable steps can you take? First, follow the money. Tropical deforestation is primarily driven by global demand for a handful of commodities: beef, soy, often used as animal feed, palm oil, timber, and pulp. You have power as a consumer. Reducing meat consumption, especially beef from unsourced origins, has a direct impact. Look for products containing palm oil, palm kernel oil, or soybean oil, and choose brands committed to deforestation-free. RSPO, Roundtable on Sustainable Palm Oil, certified supply chains. While no certification is perfect, it represents a demand for better practice. For wood and paper products, look for the FSC, Forest Stewardship Council, label. These choices send a market signal. Second, use your digital voice. Follow and support organizations that do on-the-ground conservation and scientific research groups like the World Wildlife Fund, the Rainforest Trust, or local NGOs in tropical countries. Donate if you can, but even amplifying their message on social media raises awareness and political pressure. Third, think about your financial footprint. Many large banks and investment funds still finance companies involved in unsustainable deforestation. Research where your bank invests. Consider switching to institutions with strong environmental, social, and governance (ESG) policies. There are now apps and websites that rate companies and funds on their deforestation risk. Fourth, become an advocate for policy. Write to your political representatives and demand they support and strengthen laws that ban the import of products linked to deforestation, like the EU's recent deforestation regulation. Support trade agreements that have strong, enforceable environmental clauses. The political will is created by constituent pressure. Fifth, educate yourself and others. Watch documentaries, read books on ecology and soil science, and share that knowledge. The more people who understand that a jungle is not just a collection of trees, but a symbiotic superorganism rooted in its soil, the more collective we will have to protect it. Finally, support the science. Citizen science initiatives and platforms sometimes allow people to help classify camera trap images or soil data. More importantly, by valuing basic scientific research, we fund the discoveries that reveal these hidden connections, which in turn inform better conservation strategies. On a planetary scale, the protection of tropical forests is one of the single most effective things we can do to mitigate climate change and preserve biodiversity. And that protection is meaningless without protecting the soil. When you support a rainforest conservation project, you are not just saving tigers and monkeys, you are preserving the most advanced biological network on Earth, a network that holds secrets to medicine, climate stability, and the very principles of life's organization. The shocking truth is that this war beneath our feet will determine the future above our heads. The jungle floor is a testament to life's resilience and cooperation, but it is not invincible. It needs a global constituency of people who understand its value. That journey starts with you, right now, making a decision to pay attention to the world you cannot see. So here is my direct call to action for you. First, click the subscribe button and turn on all notifications. This channel is dedicated to uncovering the hidden systems that shape our existence, and I need you with me for this journey. Every subscriber tells the algorithm that this knowledge matters. Second, like this video. Directly boost this content, allowing it to reach more curious minds like yours. Third, and most importantly, leave a comment. Tell me what shocked you the most. Was it the talking trees, the bacterial drug factories, or the termite skyscrapers? Your comment fuels this community and guides future videos. Fourth, share this video. Share it on WhatsApp, Twitter, Facebook, or just tell a friend about it over coffee. Spread this understanding. Awareness is the first step to action. We've traveled together from a single leaf to a global crisis, and now to your personal power. The silent war needs witnesses, and it needs champions. Be one. Start by clicking right now. Thank you for watching, for learning, and for caring about the unseen, indispensable world beneath our feet.